Sure, sure. Yeah, well, first of all, thank you very much for having me. It's a pleasure to be here. I've seen a few of your pods before, but when Constantine asked me to come, I was really happy. So I'm Mazeyar. I was born in Iran, but I grew up mostly in the US. And then I did my master's in AI from the University of Bologna, actually the oldest university in the world, and I still live here. And I guess that's kind of how living in Europe, being part of the AI scene, that's kind of how I met Constantine, I guess. So through Twitter, and when I did my master's in like 3D reconstruction, which is like photogrammetry, nerf, Gaussian splatting. So it's like the field is inverse rendering, where you take like images of a scene or images of a place, and you want to make a 3D digital model. It's a subspace of digital twins as well. This has existed for a while, since the 80s. People have been taking images and making mesh like or depth maps out of it. It's just another form of photogrammetry. So so there are many different primitives that you could use to show a 3D object. Um, the most famous is obviously a mesh, which is triangle. But a really new one that came out, you could even use neural networks to render the scene. Like the scene is embedded inside the neural network. That's called a NeRF, neural radiance field. Gaussian splatting is the newest form. And what it does is the scene itself. If you look at any scene, if you zoom in, you will see a bunch of little 3D Gaussian distributions. So actually, all it is colored Gaussian distributions placed in 3D. And this actually, if you click on that little photo, the diagram, there, yeah, that one. Yeah, you can see like what it. Sure, 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 sure. Perfect. This is from the original paper. So what you do is, once you have like your photos located in 3D, you can make SF. This is called SFM points, structure from motion points, which is just a sparse point cloud. And then you convert these into Gaussian distributions, and then you could do this training loop, which is you so you have the camera, which is the ground. Oh no, you have the camera and you have the Gaussian splats, so you could project that into a 2D, and that 2D has to match exactly the image that you provide. And it's actually a overfitting task, because you give it a bunch of images and you want to overfit your scene to match these images directly. And that's how you get an accurate 3D reconstruction. And then you could project it in 2D, project it back to 3D, and then you could take the loss here. And the really cool thing is that this loss that they show is differentiable. So you could just do these projections, which are rather, I wouldn't say simple. You kind of have to do them by hand. Uh, but you can find a gradient between the 3D Gaussian and the 2D image, and then in any machine learning framework like PyTorch or TensorFlow, JAX, you can write a for loop that trains this, and then you recreate your scene uh, out of this, just by moving 3D Gaussian distributions around in 3D.
So,
Um,
like it's basically like I think we talked about it before, but like I think it was really interesting where you explained it like basically abusing overfitting,
yeah, yeah.
which
So
is
you so this is 3D reconstruction. We give it images, and our constraint on the problem is constrained in a way that says the scene, once you have a 3D scene and you rasterize it into 2D, it has to 100% match this image. So the constraint is exactly the image, and we're not generating like tokens afterwards, or it's not a generative task. It's a regression reconstruction task. And these such tasks, when you have an image and you want to match exactly, it's an overfitting task. Yeah, so you can do, and the more images you have, the more constraints you have over the scene. but overall it is an image it's an image overfitting task. And what's cool about Gaussian splatting, it's a really important point, is they're not just colors. Um, a Gaussian does not have a color, it has a viewing lighting function. So where you view the Gaussian from, the angle, the alpha and the theta, this changes. It's encoded through spherical harmonics, which is a physics term. A spherical harmonic is like a Fourier transform on top of a sphere. So it's a function that just changes over a sphere. So it allows for the two angles of the viewing directions. So what it has, each Gaussian has, it's called view dependent lighting. So depending on what angle you view the Gaussian from, the color could change as well. Now, this is really cool. Phil, if you want to go to the other link called, and I sent the super splat in the chat, we can look at a few Gaussians. This is super cool because it means your scene had in the
The last one is the most recent one.
yeah, the most recent in the chat. This is super cool. Yeah, yeah. So let's click on that. Oh wait, click on this burger. This burger is insane. Or also one of the bees, like the one of the insects from this, or the butterfly. Or just press play. Just press play on this video if you need to fix something.
But
So this is
is
a
the video visible for the podcast, or is he setting that up? Oh, okay, but the video
ah.
is visible, right? The screen.
Let me.
Yeah. Okay.
Yeah,
Okay.
yeah.
Okay.
The video is visible. I just watched it through Twitter.
Gotcha. All right.
Um, so yeah, so all this is what you can see here is this butterfly. This is a really good company. I think maybe they're even German. They have a 3D rig, and yeah, Constantine, you got it. The Germans are actually really good at Gaussian. I mean Gauss himself, famous, one of the greatest German mathematicians of all time, maybe greatest mathematician ever. So they have a 3D rig where they take really good micro photographs and they take like 100 around this. Um, and then they do a training. But I just want you to look at how the wings of the butterfly change as it rotates. The colors. So where you look at the wing of the butterfly changes how you could move it around with your mouse if you want, just to look at it for yourself. Um, the angle that you view the butterfly wing completely changes. It has like lighting effects, specular lighting. It could even change into any other type of lighting. So that means the lighting effects are baked into this scene, which is what you can't have with meshes. Meshes don't have this option to have a lighting effect baked in. You would have to do a if you have a mesh, you would have to have a PBR, which is a like a function. It's its own function where you give it like the surface metallic, the surface roughness.
But you could
Um,
pre-bake them, right? So that's like if you have like a
yeah,
normal mesh and you could pre-bake the shaders and then just
yeah,
yeah, exactly. So you but yeah, but it's not like yeah.
yeah. It's
Just
pre-baked.
just
So
I
this
just
is
had it in mind because like when you do like work with 3D objects, you can
mhm.
pre-bake it so the performance is better on the browser.
Yeah. There's no. So what I'm saying for like a mesh, what you would do is you would have the if you have or let's say like a triangle to simplify a mesh. That triangle would have to have some surface properties, and then you have a light that interacts with that triangle, and you could like let's say you can move the light around in the scene, and then it reflects off. You do a calculation off the surface, and you see the color or the reflectance. But this yeah, so here every single Gaussian has its own lighting property, and it's not predefined. You don't need to define it. It's trained into it. Um, So it doesn't mean you could exactly there's like a field of research which is extracting these properties out of it into a more understandable way. like in a like a explainable matter, the same problem we have like with the explainability of LLMs. Everything here it will look exactly like the camera data you feed into it, but the lighting is baked into each Gaussian. So each Gaussian has its own lighting parameter. And these parameters could for just for lighting alone, it could be 45 parameters. So like imagine RGB is like 3, but you could have like 45 lighting parameters. So pretty much every scene, every kind of lighting condition you could imagine could be baked in. Um, and this is also just a bit easier to render. It's like easier on the CPU because you don't have to do like the whole ray marching. For example, if you take a scene in a really reflective area, um, with a mesh and you want to like do it like a highly realistic scene, you would have to do like a lot of ray marching to get this representation out again. Here, it's everything is baked into it, so it's like it's memorized into each Gaussian, so you don't have to do that again. And you can see some of these files. For example, this is a very I think if it's highly accurate. My favorite are the bumblebee.
Yeah, the
Um,
B is insane.
you could even see all the little pollen.
So what I found crazy about that is that like still like even when like as you explained it also it's just like Gaussians, but like how
Mhm.
accurate the hair is, right? That's
Exactly, because
always
God,
like crazy
this
to
is
me.
like another thing. This is just another aspect about reality. Is like in reality, there are way more Gaussian distributions than triangles. So hair is like, if you I've done so many of my cat or something, hair is so good for Gaussian splatting. Hair could be easily modeled by Gaussian distributions, but it's really difficult to model hair with triangles. But on the flip side, if you have a really flat surface triangles are better for the flat surface. But if you want something that's like but even they could do flat surfaces. But if you want to get something like fuzzy hair, plants, flowers, anything in nature, human faces, it's just so much better with Gaussian splatting than anything else. And also the files are really small because there's new compression methods. Um, So you could like another thing to look at is if you scroll down a little bit, you can see the size of this file. Oh, so this one's 9. So the last one was 14. The last one was 14, but this is 91, so this is not compressed. But there are newer compression methods, so you can just put these. You could easily encode one of these into your websites if you want to embed a 3D model. If the Gaussian splatting version of it exists, I highly recommend using this platform, which is it's called Play Canvas. It was acquired by Snapchat, and you could easily just embed one of these into your website. So,
This is
uh,
But like I
yeah,
think there's a problem, right? When you the moment you want to work on the Gaussian, like for example, change something about it, it's basically
you need to
really hard, right? So
start
getting
from
a
scratch,
mesh
right?
back from the Gaussian is super hard, right?
yeah. So Gaussian is kind of like you have to once you have your scans, uh, once you do your images of something, your Gaussian is pretty much deterministic. Uh, so if you do have lighting that is again, Gaussian has view dependent lighting, but the lighting is baked in, as in you can't change the position of the light source. You can see in this video, for example, uh, like the reflectance and the lighting is already baked into the scene. So you can't change where the light is emitted from. You could only change the viewing angle. But all other things remain. And another thing about Gaussian, if you zoom out really far, you will see something
Is there a way to
people.
zoom out faster? What's this?
Well, because I'm trying to get
Sure.
you to do it out like out of distribution. Like, yeah. So like you see when you go, I mean, this is maybe obvious, but realistically, if even a Gaussian looks good when you're only close to the like where the images were. Um, so what this means is that if you do a Gaussian of like if you take photos down a path and you go in a straight line and then you walk away and after you do the Gaussian spot, you walk really far away from that straight line. Like you go sideways view of it. then you start losing information. And you can see here, like the higher up you go, the like yeah, from this viewing angle, the geometry starts to break down because over here there weren't that many images taken. And you can kind of see the ground. The ground actually, if you look at the ground, is really interesting. So this reflectance isn't actually a reflecting directly off the ground. What it is it's Gaussians inside of the ground. If you just like go into the ground, it's Gaussians that are baked inside to the ground.
Okay. So
That lighting you see is
it's kind
actually
of see
on the
through, right? In a way.
yeah. And this is another area of research to make it less see-through. But this shows how lazy this is. So if you look to your left, the reflectance of the shells. So what you see on the ground is the shelf being reflected off the ground, right? Uh, but the easiest way for the Gaussian model to represent this is to actually bake geometry into the ground, which is why you see the white shelves inside the ground. And this actually just shows how lazy gradient descent is. Gradient descent is the laziest method to produce anything. This is again overfitting. Um, but so you really get to see these models, instead of baking this as a lighting property, it bakes it as a geometry in the ground. And this is the same thing. It's maybe you could say almost a hallucination, but so when you play around with these and you play with more difficult things like reflections, it is completely a you will see how overfit it is. And really the only way to fix this is to not move that far from the camera, albeit there is newer research that is trying to take care of this reflection problem. But in my opinion, it's not a problem. It's not a most pressing problem. I think that developers, if you want to develop this, embed it into your own website, the best thing to do is to limit the range of movement in the camera, so you're not going too far away from the camera. And also, if you're a scanner and you scan really well, these type of problems go really away. Um, but again, this it just shows that okay, it's a really advanced method, but uh, I think one of the biggest drawbacks is that it like really learns, like it overfits the scene to the point where reflections become geometry.
Like, what do you guys think of? Like, what I would think would be also interesting if we, Mazeyar, quickly could go over the 4D splats, because it's super, I think, neat, and then maybe talk a bit about the real world applications, because like we have a client that's using Gaussians in real life, I'd say, and then we could also talk about Splatting.
Can I
That's fine for you
maybe
guys.
because we kind of were at this topic of like capturing these right now, and
Mhm.
in this case, you said there's like multiple things the capturer could do to make this better.
Yeah.
Because I'm super interested in how important, like what's the ratio of importance when it comes to the person creating the splat versus the person capturing the source material. Like what's the
Oh, it's the source material is probably the most
because you
important.
just pipe it through some already
Yeah.
predefined function, right? Yeah. Okay.
Yeah, there are some hyperparameters, like a few hyperparameters, maybe like less than 5. But those parameters are really predefined for you. But it boils down to how good the capture is. So when you want to do a capture is you want to so everything you want the viewer to see in 3D, you have to get from multiple viewing angles. Um, for example, this capture here, what I would do is I would uh, really the best thing to do is to have a 360 camera. Um, and it's you want to cover like 3 different levels, like from the ground, maybe your waist, and then a little bit higher. What I would do in a room like this is I would probably take the camera and just walk around like a little bit and like the game Snake, try to get as many viewing angles as possible. Um, and then that would make a really good set because you have 3 different levels and you have the 360 camera, which could be broken down into smaller cameras, like viewing from different angles, and that would be as much as you could do. But let's just say you have a DSLR camera, that's also doable. So I would do a 360 around this thing in the center, I would do a 360 but facing the other way, capturing the shelves, and then maybe I would do it from like all the corners of the room, take a bunch of different images. But I would say this scene alone is probably it has to be over 200 images, way more than 200 images if you want something of this quality.
So did you
And these
later?
images,
Sorry, yeah, go on.
mm, and these images, you have to make sure they're good quality as well.
Okay.
You don't want any moving objects inside of them. You don't want them to be blurry. Um, your autofocus and aperture have to be locked. Make sure that remains the same for all of them as well. And then you could have a pretty good splat. So it takes a little bit of time for people to get accustomed to what makes a good splat and what doesn't make a good splat. But
Um,
um,
does the
if you
does the
just try it yourself a few times, you will get the hang of it.
does the person who's taking the pictures need to keep note of like where from which location in the room he's taken each picture, or is that like
No, no. So that would be very difficult. So what you do is first you put it into a SFM software. That's the initialization. That's the first step before a splat. Maybe I should have said this. And you don't have to know anything, like, because that's really impossible. Like you have to have like the camera down to the centimeter accuracy. Um, and then that SFM software, it's called Structure from Motion. What that does is that places your camera into 3D. It's the image alignment. So it says these. So let's say you went 360 around object, it will place those images exactly relative to other images in 3D. Like
yeah?
exactly. If it's a good quality image set, there are some problems with it, but so this what it works briefly just to explain how it works is that every image has edges and corners and these key features. So if two images from two different angles have the same features, like a fingerprint, then you could align them in 3D. And if you have enough of these that are like closely relative or related to each other, then for the whole data set, you can find every single point in 3D. Maybe you could just Google something called cold map, COLMAP.
Cold map or
Cool.
maps? Ah, coal.
Yeah,
That's it.
yeah, yeah. You can see they did this
Yeah.
in Rome. All these little dots is like the cat where a camera is placed.
Mm.
Okay.
Um, so it's just like it's hard to see because this is such a large scene. But what you can realize is that uh, the whole point of this is you don't need this information. Like I don't have to pre-record where I was standing and taking the image, and that'll be impossible because you need it to be down to like centimeter accuracy. The whole point is an algorithm could take any data set, any images, if they're of the same thing, and align all those images in 3D. Another point is that it's not a LiDAR SLAM solution. It's using only RGB data to align in 3D,
Wait, so
which is
is it the case that like you're taking the images and determining the location from which they're taken, or is it the case that you're using a piece of software that just records from which position you're taking each image?
no. Your phone, your images don't have no metadata. You don't record it.
Oh, okay. So it's
The
deducing it.
algorithm, yeah, the algorithm
Okay.
finds it for you. You can use 100-year-old black and white analog photos, and it would place them in 3D.
What's the
Um, but
what's sorry? Yeah, go ahead.
yeah, it's just pretty much what it does is when you have these like key features of an image, um, for example, let's say the Louvre, it has a bunch of lines, it has a bunch of points, ceiling points. These from two different angles, you would see this approximately the same features, and then you could match these up and then do some linear projective algebra to find a relative pose. Like this image, if it was here in 3D, these poses do match up. Um, and you could do this for like they do it for 21,000 photos, right? It's like it takes a really long time. But this field is also always improving. Now there is a method that uses transformers to do this, using only vision transformers, but it's really complicated, uses a lot of GPU memory. So this field is like eventually just gonna go to transformers probably. Yeah,
Is there,
it's
because we
really
talked
cool.
about
Like it.
file size earlier, right? Is there, so can I assume that this is fundamentally going to be larger file size than the other one we just viewed? Or not really? So is file size dependent on the input image size or not?
No, no, no. So this you have 21,000 images here. This will give you a point cloud. This returns you where the images are in 3D and then a point and a very sparse point cloud, right? Um, this is not what you view in. So this is not like a. This is a if you were to view this in 3D, it would look actually really bad. You would just see like a very like every like only here because there's so many photos you could see the Colosseum. You can't even see other places. Like you can't even I could identify these like Palazzo Venezia, like this road and these buildings, but you can't actually see what they are. Um Now this point cloud, this this is what initializes your initial Gaussians.
Mm-hmm.
Because let's say you have a bunch of so now that you know where the images are, now you know where the photos are placed, you need something to initialize the splats. And the best thing to do that is just to use the I don't know, to use the point cloud that Colmap gave you, and then you could initialize and start your training. But this is like a completely different thing here. So what you do is you convert this point cloud into Gaussians. Um, but when you output the Gaussian, you don't need the initial point cloud. You don't need the camera poses or even the images that you use to train them. But you can take like you could take 100 GB of images and
Mm-hmm.
potentially that B I showed you, that B was probably like half a gigabyte of images.
Mm-hmm.
But the Gaussian splat of it is a 3D representation, so it actually is probably much less information than those raw images themselves. The these two are not actually like the number of
Okay.
images to the size of the Gaussian. Maybe they're a little bit correlated, but it's much less in weight size.
So what actually makes the size of the, is it actual model size, or what makes the size of the end result Gaussian thing?
The number of Gaussians themselves.
Mm-hmm.
So every Gaussian it's not it's a really advanced point cloud because a Gaussian has, let's see, it has RGB, it has a quaternion for representation, so that's 7. It has an alpha, that's 8 bytes. It has a elongation, so uh elongation along the axis, so that's 12 bytes per Gaussian, and then you could have up to 45 of different 45 bytes floating point values just for the coloring,
Mm-hmm.
for the spherical harmonics. So a point cloud, what is a point cloud? A point cloud is RGB in position, right? That's six different values. A Gaussian could have 45. Um, so every Gaussian compared to a point cloud has much more information, but the idea is you need much less Gaussians to represent a scene with than point clouds.
Mm-hmm.
So that's kind of how it's compressed. Uh, Gaussians, if you do a large scene, if you do like an interior, the difference between the size of a Gaussian is could be enormous, right? You could have like let's say I do this scene behind me. Um, this beam over here would most likely be made of a few Gaussians, right? So it's like really big. But if I have like a painting or something that's more high detail, that would be a bunch of compressed Gaussians inside of it. Um, so the cool thing is that the training makes it super lazy. So it is able to like find like an optimal representation with the fewest amount of Gaussians. Um, and then you could do further compression on top of that. Like the compression I'm talking about on top of that is similar to like JPEG compression, file size compression. So what you do is when you have a splat file, what the splat file is like what I just mentioned, these parameters that represent each Gaussian. On top of that, you can do like JPEG type compression. to reduce that file size even further. You can see this like really cool. Oh, this building here is really cool. If you want to click on this, Jacksonville,
Mhm.
this was made with. This is a new method. This was using satellite photos.
Interesting.
So
Satellite, not
no
even drone.
no,
That's
this is
crazy.
just satellite. It's a mixture between satellite and diffusion models. Um, so yeah, I mean,
You know what I'm
you
thinking,
think about
right? Constantine, I'm thinking
Yeah.
Palantir for
I-
yeah,
Palantir
yeah.
for lead
Oh,
gen.
yeah. Palantir was hiring Gaussian Splatting engineers. Palantir is fully hiring in this role. Defense is using it. ArcGIS softwares like this is such a powerful way to represent 3D and in such a compressed manner that and it only uses 2D images without extra information. That's there's a caveat there. If you do have extra information, let's say you just happen to know where your images are in 3D, you
Mhm.
could use that to speed up the image alignment by a lot. As a prior, as a pose, they're called pose priors. But for example,
Oh,
this is just
wait,
satellite.
is this maybe the reason? Because like we have a client that are using this in the fashion industry, and they have those like full body scanners where you can go into, and they do
Mhm.
two images, and then you have a Gaussian model from
Yeah.
the person. Might this be the case why their pipeline is way faster because they know exactly where all the cameras are? So
Yeah,
that
so let's yeah, like let's say in the beginning you didn't know where the cameras were. And then you do this call map alignment, you get all the camera poses. It's always good to like start it like even day to day to start it from the beginning because this has to be really
Mhm,
accurate. Then for the next image or the next Gaussian spot, you could just use the same poses.
mhm.
Also, let's say you have I really like the flower bed. If you go to the top, if you look at the flowers, um, let's say for another example, you have your camera phone and you have IMU, so your like gyroscope information. Um, that could be used as a prior to help speed up Gaussian splatting, but then you need to write some software to extract that and use that. But really, the realistic thing is, it it's only if you have like extremely large scenes and like a lot of cameras, you need like priors. Um, but this is like I love this scene. This is such a good example of Gaussian splatting in nature. Tulips and flowers look really good with splatting.
Mhm.
I
And
think it
how does it
always
look if you
crazy
go
how
into
the
the
deep.
flowers and look up, Phil?
What do you mean? Look up.
Like get in there and then look up. Like you're lying on like you're lying on the grass
I don't
looking
think
Rose
up at
it's
the
going
touching
to be
sky.
grass.
good, right? Yeah.
Yeah, because
'Cause there's no
yeah,
data,
that's what I
right?
was thinking.
Yeah, there's
Yeah.
no data on
But
that
still
scene.
pretty, it's not as bad as I thought it would be.
Yeah, so like these things um for example, like Gaussian splatting, if you like you would see if you take like really like if let's say you're in a room and you take a like a really high elevation viewpoint and you only take like your things from the higher elevation. Um for example, the things underneath the table is not even going to be visible. Like the
Right, yeah.
second you look underneath the table, it's just going to be pure blurry. There are some like newer things which are like not even that new. I mean like 2 years old, but they use diffusion models to get like uh diffusion models to make like to get these views for you.
So it's like fake,
But they
right?
don't
It's
work.
just generating
Yeah.
stuff that doesn't really
Yeah,
exist.
but speaking of generation, there's now World Labs, which is like
Was is
my
this
fa
also Gaussians by Fei Li?
yeah, yeah. So
Do
you can
they
look
use
at
Gaussian?
Oh, what's the
World Labs,
word labs? Okay.
Labs.
Mm-hmm. Oh no,
Um,
it's scroll checking.
if you click on Marble Lab, they call it Marble Labs now on the top.
Is this? Oh,
The top
oh.
right corner.
Top right.
Yeah.
So you can look at some scenes. I don't know if you could like look at them. So these are yeah, so what they use is they use a fully diffusion. So like the scene, I mean the room, not like the hands or anything else or the cursor. The room itself in this This is a diffusion model that outputs Gaussian splats. And then they import this into like Houdini to do like relighting. But what they've done with Marble is they built a large diffusion model that literally outputs splats. But you can really do like some other things with it, which is like how do you say you could ask it to do really creative things. Like you could say like a medieval town or like a spaceship or something. I really like their model. What I think it's like I don't know the exact use cases or what you would exactly use it for yourself. But and it's a very early model, but you could ask it really creative questions, and then the whole thing without ever having to scan, it generates it for it generates a model for you. You could give it a prior image as well. Um, like you could give it an image of your room, but it would hallucinate some like things that don't actually exist in the room.
So you don't
It's
I
have
think
to
quite
maybe
check
that's
trippy.
the
also
images, right? Basically, that's the
Oh,
saving.
you could give it a text. You could
Yeah,
just give it a
but
text prompt.
for if you want to create an splat of your room, you could basically you could be lazy and just use this, and then it's going to be off obviously because it's like it doesn't actually have the information, but you could just pass it one image probably, right, and it would create
Yeah,
something.
yeah, this is the cool thing. Yeah,
Yeah.
but like for like the cool thing would too is like say you could make an image of your room and you could say make a spaceship version of this, right? So it look like your room is like a spaceship
So
inside a spaceship.
so
Or
what's
or you could say just one image, but it's always trippy because what you do is you do it and then you like look back behind and it's like a completely different room. Um, so it's like I always like find it's a really interesting experience to do this with places you know well.
but
Because it does hallucinate in a place that you might know very well, and you're like, wait, that's off. That's so weird.
but that's like
Um,
so this right here, right? Is this just something else, or because this seems like it's actually generating like models, right? Like it's generating GLB or FBX models, or not
yeah.
really?
So this. No, so I think what they're doing is they're just converting the splat to
I
these
think it
models.
said like you can upload it there. So you could upload your GLB model, place it in a scene, and get that
Yeah,
like.
but how would you chisel? How would you? Okay, maybe it's literally just uploading. Yeah, because it sounded to me like you can. Uh,
I read that like you upload your GLB model and it's in the scene.
okay, so it fuses the splat with an actual.
I
3D.
haven't tried this out to
Yeah.
be fully honest. I haven't tried this
But I
feature
think
out.
what's also nice, Phil, if you open the like 4dv.ai thing I sent you on Telegram, or you can also type it it's
Now I have it open.
4dv.ai. Yeah, exactly. This one is also super interesting. I
Yeah,
think
this
it's
is
like the
gonna.
step before the whole world building. But this blew my
Yeah,
mind when you sent that to me, Mazeyar. It's crazy.
yeah. So this is a 4D JS. It's a Gaussian splat, but in 4D. Um, this requires a lot of cameras, and you have to have their cameras that also record. Instead of just recording one image, you just record videos from your camera, with your camera array. So this is made of like 30 cameras or so. Um, and so what it actually is the file size is not that much bigger because you start with the Gaussian splat, like initial Gaussian splat, and then every frame after that is you're just moving these Gaussian splats or creating new ones to. Oh yeah, this is the back of this guy's. Actually, I think the
It's
back
weird,
is like
right?
the
Why
most
didn't
interesting
they
part.
record from the back also?
That's it just requires so many cameras.
Yeah.
Uh,
I think like if you go to the dancer, I think she is like
yeah, it's a lot of camera. It's a lot of data you're talking about here. Uh,
yeah, see.
yeah, so she's 360.
But
Um,
yeah.
if you have 160 cameras and at 30 FPS, so that's uh 3,000 images for just one. Like, oh no, there are more than 3,000 images for just 1 second, right? If you consider a Gaussian splat for like 200 images could take 2 minutes render. Now you're talking now not for 1 second you have 3,000 images. It's a lot of rendering. But the good thing about this is that you move the Gaussians frame per frame. You're not generating a new splat file every single frame.
Mhm.
So you're able to compress a video down relatively well. And when you have a really like the magic of Gaussian splatting is like when lighting, camera quality, everything is really good.
But
You're
like
just mind blown. Yeah.
what I never got is like isn't this used more in like in games? For example, like a background scenery or something. If it's like
I mean,
if
there's
you
no
have like the
dynamic lighting,
lighting.
right? Which is probably the bad part. Like I,
But like if you have a scene, for example, you could like at least in the distance, couldn't you just like bake it in well
Oh,
enough?
yeah, I mean, there's like first, let's just take like a game like Call of Duty, like Nuketown from Call of Duty.
Yeah.
Um, like you don't need to move the lighting in Nuketown a lot. But what I mean is there are a lot of actually, Phil, to answer your question, a lot of people do. There's a company that does this. They have a really good rig, right?
Mhm.
And this really good rig, it's like a car rig, and they drive down the street. So they make like let's say like a 3D Gaussian spot Google. And then what they do is when they want to film someone driving in a scene, like a VFX, what they do is they have a car, they place the camera here, and then behind them in the screen is just representing the Gaussian splat.
Mhm.
So if they move the camera around the driver in the car, the scene updates, the Gaussian splat updates with that camera movement. And it's actually really hard to tell if it's being filmed outside or inside. But you can really do some really cool things in VFX. If you have a really large screen, like this example is like really common. If you have a really large screen behind you, and you move the and you know the so you have to have a camera with some sensors where that camera is being filmed, then you like essentially don't need a green screen. Like that screen behind you, it's like it just rendering the Gaussian spot. And actually, a lot of the times, you can't even tell, because the screen is just a background object. You're not looking at the pixels, but the screen is moving very accurately with the camera, and the Gaussian splatting looks good enough that for the background, it looks like a real background. Uh, so for example, you could film somewhere you could scan a place, go back to Hollywood, and then like refilm your person around that scene. Um, I think it has huge applications in VFX.
Should we talk about real
Yeah.
life applications of this? Because we're kind of going into this direction anyway, right? Because I mean, this is nice and all, and then gaming, I can see it for like environments, right? For everything else, it doesn't really work, I don't think.
Mhm.
But for environments,
So
what
yeah,
I
Yeah, I
think
mean,
why it's not being used, and I'm not like a huge game dev, but I think it's just probably because this takes a while, right, to create these. Like it's not like just okay, I'm just
well,
gonna.
yeah. For example, it's only useful if you want to create something that exists in the world. If you want to create a
Yeah.
fictional place, like a Call of Duty map,
So I
like
think it's just
Nuketown.
easier to use current workflows, right? Because you can fine tune them later, right? If somebody doesn't like something, you can go in and just okay,
Yeah,
I'm
like
gonna move
you
this
can move the
one
car,
phase
you can
like
move.
two
Yeah,
two 2 inches back, right? But then if
yeah.
you have this
But for
splat and it's done, right?
Mhm.
You put so much time
Yeah,
and
yeah,
energy into it, and you can't change it. If
yeah.
but that would change it
For
with like world gen, like the world models thing, where you could just rerun it.
I think
You could
if
just
it's
say
tight,
like,
but I could also see it for like stuff like I don't know if you want to build like an artsy game that uses like stop motion or something, right? It would be really cool because you don't need to like you can do like stop motion 3D, use Gaussian splatting, and create like really cool stuff probably. Um, but everything that's like
Yeah, for example, like for generating a large scale gaming scene, I just wouldn't like maybe do it right now. But if you want it for game devs do use it for scanning smaller objects that they want to put in their
check out the
scene. For
reality
example,
scan thing I sent you. So that's exactly what I think Mazeyar is talking about.
this, or what do you mean? Oh,
Um,
reality scan is this
no,
one,
no,
right?
the first one. Yeah, the one
Yeah, I
before
could
that.
see it, for example, before we talk about this, I could see it because I've recently played the Indiana Jones game, right? And it's set in like Rome. And it's
Mhm.
like trying to replicate real life one to one, right? So you could probably go to Rome and scan in those places, right? I mean, this is
Yeah.
being used anyway, right? It's like it's not
Yeah.
splatting, but it's like, or is it actually splatting?
Well,
It's photogeometry
the-
or what it's called, right? Is this the same thing?
yeah. So for example, if you are a designer and you want to just Gaussian splatting is really good. Like this whole thing speeds up photogrammetry
Mm-hmm.
because now there's so much funding going into photogrammetry, uh, that there wasn't before. So even if you are just like a regular game dev, you want to do everything old school, you want to recreate all your assets from hand. Why not make a scan of it first and
A
then just do
reference
that
point. Yeah,
yourself and have like the control you want?
Mm-hmm.
And it would, if you don't even want to like have the splat in your game, you could still use it to help your workflow a lot. Uh, that's another point as well.
Yeah, that's interesting.
Yeah. Like talking about that, just like play the video real quick. It's super nice. And it's also, I think, a great experience for like how ARKit, whatever they use here, is
With Reality Scan,
implemented.
you can create photorealistic 3D models of real-world objects
Doesn't
using your
this
smartphone.
AR
Oh,
No,
Here's
you
how
don't.
it works.
It's just, I think it's just like, it also shows, I think, Mazeyar, correct me if I'm wrong, I think it's not the same thing as the Colmap thing, but I think for me, at least, this is a nice visualization of what the Colmap thing does, because it
Yeah,
like
this is
puts,
SFM. This
yeah,
is pure SFM.
it puts the images in 3D space, and then it shows you from which sides you have to capture more. If they are red, you need to do more images from
yeah, I've
that
used
area.
apps like these. They are, but okay, interesting.
I mean, it's very similar to ARKit.
Mhm.
ARKit's really good because ARKit has your gyroscope data. It also has if you have a phone with lidar, it has your lidar data. So Apple has done really good job with ARKit, and it could be you could use ARKit to make Gaussian go from ARKit to Gaussian spotting, but probably not rendering Gaussian spotting directly on your phone yet.
Can you integrate the data from the lidar sensor into Gaussian splatting?
Yeah, it's a good prior to have. That was one of my jobs, one of my consulting jobs. Not it was using not another lidar data set. But yeah, lidar gives you position and it's a point cloud at the end. So you could use that as an initialization. You could actually, but lidar gives you too many. You could actually reduce the number of points from the lidar.
Mm.
But yeah, lidar, of course, it's just extra information where you could.
So Konstantin, is
So
this
as
Super
app
for
easy.
the
doing anything
practical,
super interesting?
yeah,
Oh no, sorry to interrupt you.
No,
Sorry.
no, it's just like
okay.
I think it's just nice. If you haven't seen it before, I think it's a nice
Yeah.
visualization of the SFM thing. It's a nice
That's
like
right.
just so you can see how the capture works, kind of.
Yeah, that
But
was
It's
just
super
I
nice.
mean, maybe this is obvious, but like, is there like interest to use this tech for like training robots to move in 3D space, et cetera, et cetera?
Yeah,
It's probably like I feel like the
of course.
biggest.
That's a huge thing that World Labs is doing. You can actually export. So the NVIDIA does a lot of research in this. You could actually export a Gaussian. If you do a really good Gaussian spot, you could export it into Omniverse, which is another NVIDIA app for robotics training. There's a few papers called Real to Sim. So a lot of this Omniverse stuff is like traditionally just meshes, but Omniverse has a format called USD, it's Universal Scene Description. Uh, so you could convert a Gaussian spot into a USD Z, I think it's called. And then there's another company called General Robotics, and they just have like so like one thing is to generate. So there are like approximately two different types of Gaussian spot. There are ones of scenes and one of individual objects. Um, there's another company, General Robotics. What they do is you have an object, and they take like a bunch of photos of the object, and then that object could be as an asset used to like as a pick and place. So what you could do is in simulation, you could generate some. You could train a robot arm to pick and place that object. Like let's say this Rubik's cube that has special lighting. Um, and then in real life, they show that you don't have to like it's like not one shot, but it could just interact with it in the real world. even if it's never seen it in real life before. Because the capture that they did of it is realistic enough where the knowledge transfer is good enough into real world. Yeah, these companies are popping up everywhere that are doing these types of RL robot training. It's a
How good
super
would
fascinating.
the how good would the quality be for a scene generated? Because I'm thinking of like if you had like a factory worker who had like meta glasses on or whatever, and I don't know if the meta glasses have LiDAR sensors, but let's just assume they do, or let's just imagine that they do. So if a factory worker was recording their work with a LiDAR sensor on, because I'm thinking like if you have 100,000 hours of a video like that,
Mm.
um, maybe that scares you of like turning that into Gaussian. Maybe that probably takes a lot of time, but like, because if you could do that, then that you could add that to the data set that you have that you already had for training like a 3D model, right? Or a
Yeah,
3D.
there's a company they just released what 10,000 hours. So this is an interesting point. This is called egocentric data. It's data from the viewpoint of a human. Um, yeah, so meta glasses don't have LiDAR, they just have two RGB cameras. But that's more than enough to capture. This is not so much in the realm of Gaussian splatting, it's more of just spatial compute. Um, those types of apps, they're more important just to see the hands and to like just it's kind of like the Magic Leap where you have like a wireframe of the hand and you have spatial understanding of where the hand is in 3D and what the hand is doing. But there was a
Right.
data set that just came out from a new SF startup, which all they like the whole it's just 10,000 hours of this, even more, maybe
Gotcha.
100,000 hours of this, open source. And then there are companies that pre-process this, where they put like the wireframes in the hand, get as much information as you could possibly want. Not necessarily Gaussian splatting; it could be 4D
Yep.
Gaussian splatting. But then they sell this to a robotics company where some robotics company are doing like algorithms which are transfer learning algorithms, which is like you try to learn from what a human does and then apply that to a robot arm.
Right.
Um,
Okay.
but there was a company in SF. Let me just try to find it on Twitter. But
No, I think I've seen that on Twitter.
I think I
I
saw it on
forgot.
the
I forgot what it
timeline. Yeah,
was, but
it was an
it was
image with a lot of small
yeah. It
images
just
and
came out
stuff.
like 2-3 days
Yeah, yeah.
ago. Like
yeah, yeah, yeah.
uh yeah. So these types of companies they definitely do exist. I there's no way I'm gonna find it now. But it's gonna be a huge thing. And so there are oh, I found it.
Oh,
It's called Build. It's just build.ai. If you want to go to their website,
that was a like this
What's
domain was
their Twitter
pricey.
at?
their Twitter at is. It should also be build.ai. Or I'm looking at.
That's a weird side.
It has the if you scroll to the bottom, it has that build. It has
Maybe
the
their
framer motion,
website
I
has
think.
it.
Guys, this can't be it.
I don't think they have a. About. I'm looking.
But yeah, it's
But
on.
yeah,
We don't need to find it necessarily, but yeah.
yeah, I mean, but the point of a company like this is they just do like a mass data collection, and the point will be the algorithm engineers find a way to transfer this knowledge to robotics. Uh,
Yeah.
So
and
how
in
does
between that,
yeah?
is some people like uh pre-processing it to get spatial knowledge out of it.
S- So how do you go from Splat to 3D? Because you mentioned this like as a side note, but I'm like mostly interested in that. How do you, is like
Uh,
because
the splat is the
USD
3D.
is a 3D. It has 3D objects,
I
right?
think Phil, you mean like meshifying it or making a
Meshifying,
mesh
yeah, yeah.
out of it.
Let's call it
Yeah.
meshifying.
Ah, okay. Well, there are algorithms that do just specifically mesh to splat to mesh.
And is this lossy or
Um,
something, or is it like so? How does is it?
you can look one up. It's called mesh in the loop. Mesh in the loop. Just do Gaussian splatting. Okay, first one.
Uh,
Maybe you could look at a video of it. No, it's a mixture of because so classical mesh Gaussian splat classical photogrammetry mesh has existed for a very long time. On the left is the mesh, by the way. So classical mesh algorithms have existed. There's like it's been like 20, 30 years of research. It's just trying to incorporate these into Gaussian splatting at the same time. At the end of
Just
the
a
day,
quick
a
question,
Gaussian
Mazeyar. Sorry, could you also use the Poisson surface reconstruction for that, or is it just for point clouds?
well, like yeah, I mean so that is specifically for point cloud, but let's say you take that and you try to take the understanding of a Gaussian splat, which is elongated point clouds, right? You could also just like think about it like that way. I mean, there's a algorithm called marching cubes, right? It's like let's just say you put a cube in 3D and you see where around that cube there is a surface or like something, and then the way that thing interacts and intersects that cube, that tells you where to draw the line. You can look at the picture. That tells you where to draw the line of the mesh. You could also do this in Gaussian splatting as well. Like you could like think about different ways. So you see, like if there's only one dot in the corner, you put a triangle there. If there are multiple, you could put two triangles in the middle. Like these algorithms, if you have a 3D object, there are so many representations that you could take it from 3D to mesh. So many algorithms. Um, but yeah, this mesh in a loop, this is the best one that's come out so far. And it's rather accurate. It's accurate enough. I think you could
So I
use it.
assume like stuff like what we saw earlier, right? The hairs and stuff, the grass, whatever, it's going to be probably ass, right? Mostly. Or is it just actually
No, it's going.
super
So it's
detailed?
always so yeah. Like for example, a hair will look worse. Some things look better. Some things look worse.
Yeah.
So for example, the bench might look better as a mesh.
Yeah, because it has like
But
yeah.
but the trees always look better as a splat.
As a splat, yeah. But it's like probably
So
good enough, right? For these, like for example, for these robotics tasks, you're dealing with like you're probably not dealing with like super highly detailed information like hairs or something, right? You're dealing with like hallways, which
yeah, no, but for
Barberbot
the
3000.
the thing about robots is that the splat, but you could use splats in Omniverse as well. But the thing about that is they're really cheap to create. Also, you have the good lighting baked into them. So, yeah, I mean, there's use case per use case. I would never say replace everything that is mesh with a Gaussian splat for sure. But I think Gaussian splats open up a lot of new avenues for people, especially because they're small and you can like incorporate them into your website. I'm certain that you will start interacting more and more with them in websites. Google Maps, for example, has a few Gaussian splats built in for like to see restaurants. I think it's just gonna keep growing and growing.
Interesting.
I think it's really like I think it's kind of mind blowing. Like when I saw it the first time, when like Mazeyar sent me down this rabbit hole for the first time, I was like, dude, like this shit looks great, and like you can do it like even with like real world applications. If you open the bot spot thing real quick, there is. They have those scanners in the MPI, so Max Planck Institute near where I live. When we got a tour there, we saw them, and also yeah, people use that in the fashion industry a lot to create like body doubles and stuff like that.
Yeah, I mean, I think for humans, like humans, Gaussian splatting is definitely the way to go. Avatars. Oh, the Apple avatars that they announced for the Vision, those are Gaussian splats. If you look at the new Apple avatars, they're super high resolution. Vision Pro avatars,
Yeah, I've
exactly.
seen them. Or we can pull them up.
Yeah, these
perfect
are yeah,
These, right?
these are new. Yeah, the new ones are Gaussian splats. So humans are really good for Gaussian splatting.
Yeah, because it would look
The old one was
uncanny,
ass.
right? If you would do it by hand, and also it would just look ass, probably.
But even if you do it by mesh, like doing
Nice. It takes
Doing
like
these things by
$500, right? And then it's still going to look uncanny if you aren't like goaded at what you're doing.
Yeah,
So
yeah. So it's really cool that you can just scan your face. I don't know how they scan every person's face. I
I
don't know.
think
Maybe
it's
you
like
scan it from your
5 or 6
iPhone.
pictures. You need to take like a few pictures.
Yeah,
It makes you do that, and then I think you have to use your iPhone for that. I don't think
I
it.
think you'd easily use your iPhone
Yeah.
to make this of yourself. 5.6 just to give it like the initial parameters. So this is what they had. This is a really custom algorithm. This is like a really advanced algorithm. This is nothing open source can do. Because it also talks, it also moves. It's really they have a lot of training data. What they're doing is really incredible. But it just shows the primitive, the way to represent this 3D is better in Gaussian splats.
Yeah.
I'm really happy they moved to. Oh, also Tesla for their cars they use Gaussian splat in some cases. To represent the 3D scene. They do a really beautiful algorithm there as well. So these big companies who have a lot of data, a lot of compute, they could start doing really advanced Gaussian splatting.
What would you say is holding this back? What's the main thing that, or is that just nothing that holds it back, and it's just like,
Well. This is a huge, easy way to get into unflatten.io, which I am the co-founder of and CTO. Maybe the website's not the best, but um, so a lot of it is you need a lot of technical expertise to set up these pipelines. Like I said, you go from SFM image alignment that has multiple applications, and then you have to go into Gaussian splatting, which is multiple algorithms. We just saw one that's mesh in the loop. That's another algorithm. And then you could do compression, like image analysis, robotics, like all these things on top of it, right? So you have this pipeline with multiple different avenues for each step. And each one of these is like kind of a research paper, and it's also a GitHub repository. They might have different CUDA toolkits for each of them. It's a mess, right? For each pipeline, it would take like a mess. Like I think it would take something like Constantine like a few days to set up just one pipeline. And if you want to just keep this screen here, like what we plan to do with Unflatten is instead of going through all of this work, all you have to do is you have to just all you have to do is you have to just call the API. So you just give it your images and you tell it what you want to do, like let's say mesh or Gaussian splat. And you just give it your file name and you put it onto you call this API, and it returns you a mesh automatically with your own parameters that you like. I think what's really keeping them back is first the knowledge of the pipeline, and then secondly compute resources. Because it is really compute intensive. If you want to run it locally, it sucks. Like locally, like if you have to run it on your laptop and your laptop is on your lap, you're gonna burn yourself in like 20 minutes. It, minimum time on a laptop is 20 minutes. But on a multi GPU cloud cluster, you're talking more like 1 minute. Um, it Gaussian splats yearn to be hosted on the cloud. The data center infrastructure is just much better. And all you have to wait is just for a little bit of network link, and it just makes much more sense to run these things on an H100 than anything else. But yeah, so this is like kind of what we're trying to do is we're trying to run the best algorithms that constantly keep coming out. So another important thing to know is that these algorithms update and become faster like every 6 months. So on if you're just going to focus if you're going to specialize and set this up yourself, in 6 months your pipeline is going to be outdated. So it's really important, I think, to have a universal API where another company does this for you, and they just charge you pay as you go, so you just pay for the compute you use. But you still get all that specialties knowledge set up for you in the beginning. And this is exactly what we are trying to do at Unflatten.
so it's basically something like replicate, right? Where you're like democratizing all kinds of different models.
Yeah. So
But you
that's
want
a very
to-
good question. It's a very good question. It is very similar to replicate, where a replicate puts they put like they're more of an inference provider where they put inference and you use like a pay as you go model. But for example, having a whole pipeline, you cannot just do so easily with replicate. Because you have multiple steps and each step is training and it could take 20 to an hour, depending on the size of your scene. Also, your users need a place to store their data as well, and they need to potentially they could use different parts of the pipeline. That being said, maybe in the future replicates exactly what we're doing here because it's an API and it's a pay as you go model.
Like a DevTools type company,
do you
right?
think that there's, because one thing about replicate, which I don't think, like, normies are not going to use replicate mostly, right? Because you kind of need to know your models. Do you think there is a place where unflatten would just give you the best in class? So it's like opinionated. It's just, or is the direction you want to go to more so like replicate, where I can pick whichever splat pipeline I want to use? Because I assume there's multiple ones, right? Like there's probably like,
Well, yeah, so the whole point of the pipe, so there's this, if you just look at full image to splat pipeline, this is like the generic pipeline. There you could use predetermined pipelines as well. We also plan to have a drag and drop option, so you're not just stuck to API. But yeah, we're really targeting is we want to do app developers. The app developer knows their special use case and their users give them the data and they call our API. So we could focus on many different vertical markets rather than kind of focusing on each market ourselves and producing special pipelines. For example, if Constantine wants to come and make a pipeline for fashion, he could just do that really easily. But he doesn't have to set up the entire pipeline himself. I think this is my business model, which I think would be the most successful at the moment.
just so I understand, so it would be one pipeline, right? So you're building one thing, it's opinionated, it works well, or are you building something specifically for Constantine? And you are offering this.
No,
okay, yeah.
So you could edit the pipeline yourself if you want to, or you could just use one generic one.
Okay. So it's like
So if
customizable.
Constantine, so Constantine could just call this most generic pipeline. That's fine. But Constantine, what you could also do is you could call one SFM algorithm, get the SFM outputs back, and then call a different Gaussian algorithm, get the Gaussian algorithm back, and then call a different compression algorithm and call that back.
And it's all hosted on your infra, right? And he's just paying for compute?
Yeah.
Okay.
Yeah, exactly.
That's cool. I mean, there might be issues,
Yeah, that's
right?
interesting.
Where if replicate does the same thing, but I guess it's still, they don't have any sort of.
I think it's not their market right now. So
yeah, it's not their market at all, to be honest. It would be it would be just very weird for them to come into the 3D Gaussian reconstruction market. I don't see any reason for them to do that, but
I mean, the
thing is,
focus right on this one thing and not try to do everything all at once. So
because they're really focused on
image gen, right?
Just they're being an infra provider and getting those inference latencies down. Like we were pitching to VCs and a VC goes, well, NVIDIA has a lot of GPUs. What's stopping them from competing with you and just using their GPUs to? Why can't they just use their GPUs for free and fuck you over? And I'm like, why don't they do that to everyone else? That's not what their market
so
is.
So much gas. Why are they not doing that themselves?
Yeah, they have so much free GPUs. They could just put you out of business. I'm like, yeah, they could put a lot of people out of business, but they're in the market to sell GPUs, not in the market to be a very 3D reconstruction API provider.
That's such a retarded
So the shit I have to deal with.
Like that's like who even asked this question? That's crazy.
This is what you deal with VCs all the time, by the way. This is VC trying to get funding for this for a long time. But yeah, I mean, we think it's so Gaussian splatting APIs don't really exist. We also do a lot of open source. I contribute a lot of money myself to open source projects. So and also what's really cool is the state of the art in Gaussian splatting is already open source, and it's just going to keep remain that way. We're not competing against a lot of really privately mega frontier labs. Like being a frontier lab for Gaussian splatting doesn't really make sense. There's not much like to do, as in it's not like a frontier lab has a lot of like kind of capability because they have a lot of private data and they have a lot of compute to train. But a Gaussian splatting just boils down to the math of the algorithms and the CUDA kernels, which open source can be state of the art.
And
It
what I
is at the
also find
moment.
like what's also kind of interesting, I think I also read into some stuff of that, and I had this like mini toy project. It's not like Gaussians, but like with LiDAR, and a ton of papers and a ton of resources are from Euros. It's great. Like I haven't really.
Yeah,
I'm not
yeah,
sure why
yeah.
this is. It's such a European thing. I haven't like. I'm not sure if I
Totally. The
read
Gaussian,
one paper from an American. I don't get
the
it.
3D world, well, honestly, the deployment of Gaussian Splat into phones and LiDARs and
Mhm.
hardware, a lot of that is the best deployment is Chinese, price-wise. But the best algorithms are always European. The best researchers, I mean, Gaussian splatting paper originally came out of Europe, France, and so far every like good, useful, incremental. So this year there has been 1,400 Gaussian splatting papers alone. Um, I mean, Gaussian splatting came out 2 years ago, so 1,400 papers in 1 year is pretty good. Yeah, completely, Constantine. There's a really like the main people have always been European. And Europe really just has this. I don't know why Europe. I mean, maybe Europe missed the LLM race. So the Europeans are more focused on Gaussian spotting, but Europe has a really rich history of photogrammetry and computer graphics. It's been uh, like Max Planck Institute is one of the best for traditional computer graphics. INRA from France. University of Bologna itself has done a lot for radiance fields and Earth. It's one of the best labs in the world, University of Bologna, for this topic, even though we're just like 7 people. I still think it's the quality of research is amazing. Yeah, the rest would be and like big corporations like you would say Google, OpenAI, Apple, they made no like ginormous step contributions to Gaussian spotting. Um, Maybe the best thing about Apple is you could, if in the future, train it really fast on an M5 chip. So I mean that could be cool. Um, but yeah, I mean we're still in a really niche market. These things like Apple, Tesla, and Meta, these announcements were in the past month. So so really we have a long way to go, and it's a good market if you want to get into something new.
It's also starting in the fashion industry. Like they just recently started doing that and picked that up.
Yeah, I mean,
So
so
it's also interesting.
anything like almost honestly like anything that has 3D could be very useful uh for uh for let's say, how do I say it? Like anything depending on the hey, that's me. Depending on the primitive, Gaussian splatting could replace a lot of 3D, right? So just keep that in mind for your applications.
No, but I think this looks
Gonna
great. Like I think this could actually, I could see myself using
Yeah, I
this.
think the
Like
dev
why
tools.
not? Like
Yeah,
post a
like
fucking
if I
API
want
and
to
it's
use
especially
if I
for me,
want to use something would be
yeah, especially I
through
think
this something like this.
the pre-made pipeline would be nice from like just like playing even just playing around with it or trying it. If you don't have to think, I don't have to read into the research. I can just like curl.
Yeah, I mean, no, really, Constantine, the problem is you would bang your head over CUDA toolkit
Oh yeah, yeah, yeah.
for each part of the
Yeah.
pipeline. That's the problem that most people face. And if you want to run it on Apple, you have to run it on CPU, and you're just like, fuck. Like I rather
Yeah.
just And our margins are really low, so it's you get efficient compute at low margins. So it's potentially even cheaper, like in terms of electricity, than just running it at your home. Because data center GPUs are so much more efficient. And some hyperscalers, they sell these things at a super low price, maybe at a loss as well, that reuse their GPUs. So it's actually much like we're thinking this is an important aspect, like per splat in the cents, like 10 cents or even cheaper, right? So if it's 10 cents for a splat, because that's really the only margins we could take while being profitable, running this at home just doesn't make sense.
And
Especially
you
if
would need to have the hardware anyways, right? So that's also like
and then the
complex.
expertise, and then banging your head over CUDA toolkit. Okay, if you probably don't even have Linux, you have Linux, but most people don't have Linux. Like,
yeah, especially I think I can see it especially for the like creative space. Like designers or fashion designers or whatever have Linux. Like they just don't touch that with a 10-foot pole.
Yeah, you need to make
exactly.
it. That's why I said, like, is the target audience going to be primarily like devs?
You have to make it retarded.
Yeah, you really have to have like a dashboard type situation, I think.
Yeah, we want to have a drag and drop as well.
Client. And a TypeScript client.
For the giganormies.
I don't. That's not even me being like. That's like me being legit, because nobody's gonna do a fetch, like a fetch.json or whatever. You know what I mean?
If this gets popular, somebody is just going to probably.
Well, we hope the point of this would be someone in the fashion industry does make a wrapper over our API, where they could who has connections that, like, because the same way there are so many OpenAI wrappers. I think I don't think that's an insult to a company to be an OpenAI wrapper at all. I think that's a good thing. Like, you minimize so much time and resources to use their specialty, which is them and their inference and their models. If you're going to 3D space, why wouldn't you want to do the same thing? Instead of hiring a 3D engineer, which is going to be 10K a month, you can just use our API instead, and you can be the one to many funnel for unflattened. Yeah, I think our whole thing is to create these funnels to allow developers to really get into 3D without a lot of expertise.
That sounds perfect. That sounds like something I'd do.
Cool. We and Phil are the guys without expertise.
Yeah, thank you. I mean, a lot of people say that.
Is this usable already, or are you like pre-launch?
No, we have like a MVP, but it's not going to be usable until we get funding, and then we can all go full time. Because we need to have a proper dashboard, proper payment system, API key generator. A lot of these things are going to be but we're trying to get funding first. Saying like, things are a bit shaky at the moment. The vision's really clear, it's good, but that side of the company, things are hellish, I would just say. Don't want to talk too much about it, but I'm very optimistic. It's this idea. If we don't do it, you could expect like Google or Meta to come out with their own solution doing something similar. This will be made in the future by someone else if it's not us.
There's a lot of space, right? If Google does it, I don't think it kills your thing, right? It's like,
oh, not at all, not at all. If I think if Google does it, it's great validation for us.
I just wanted to say I think it would even be better if Google and someone else does it, because then they like VCs see traction in the market and then they want to.
But stuff like the Apple thing, right? The Vision Pro using it, it's enough validation already, probably, right? It's like I think. Yeah, I would probably, if some service like this existed, I would, because I'm in the client service industry, right? I would just tell clients to like, we can also do some, I don't know, fun 3D stuff. We can incorporate it into a product, because then I know it's like, it's not going to be a hassle for me to set it up, because otherwise it would not be in budget, right? There's no way. Like, how would I do
that? Exactly. It opens up so many avenues for people who are like a little bit technical, but not. I mean, really to really use these algorithms and to have like a really good understanding, you probably need like a master's degree in computer vision. But of course, you could just set up the GitHub yourself locally and run it and just get an idea. But that doesn't mean you understand exactly the back end, the backbones.
Like cost, right? So even like
Yeah.
I could
Oh yeah,
set
you
it
could do
up,
it, of
but
course.
yeah,
You could set up an
I don't know
LLM
the
locally. You
position.
could do research. You could fine tune and have it do.
The use cases where you want to actually own the infra.
From them is that it's super important because, like, especially if they shoot those Gaussian splats with route that to headquarter or something, and
Yeah. Ever unless you have like a DGX at home, which is so expensive. Our Docker image, our pipeline is routing capabilities. Like analysis is not like real time. You could just be like, okay, here are the Docker images.
Yeah, they exist for sure. Use something like this if it existed. Even
Yeah.
do we have any last words?
Maybe the industry. I mean, it is a really exciting time for 3D reconstruction. They just keep getting fast. Move away from Gaussian from future. 3D apps instead, and I think avenue for that. The quicker you learn this and their websites somehow. Yeah, learn the file for
earlier, Phil. Like if, for example, things. Yeah, exactly. Would you say
Yeah, but well, I know at some point the camera die. Hello,
Yeah.
can you hear me?
Yeah.
Yeah.
Learn how to capture a Gaussian splat or 3D experts in like small objects, but this is a huge community. They do splats of their baby sleeping. It's nice that I think in the future, as these viewers become usable in every app, we'll know in 5 years how to do.
Like my, I don't know, my
Yeah,
completely
yeah. I mean, the
non-tech
way if you have the thing that from every angle.
Experience
Yeah,
well.
that's what I was
for
gonna
people to
ask.
Yeah.
Do you think there's space for like a
Apps that just do this. I mean, apps like existed for a long time. The photograph it's really about getting this to it's almost like a power law thing. So increase the number of users and use cases, right? If like the average person doesn't want I want to get this down to be instant, right? Years is you could do this all locally on an iPhone instantly. And research hints that as well.
something like this? So they wouldn't want to pay for their splats. They might want to use
Well, we could monetize it through other things. Like it could be the company uses your data for something else.
yeah, but if you can get a shitty version via local compute on your iPhone, higher quality version or
Like
something,
with
right?
Midjourney, you just upscale.
Yeah, I'm just foreshadowing. I'm going to talk to it. You know, bending spoons. You've heard of them,
No.
maybe.
Yeah.
You've
Bending
they're
spoons.
Italy's only decacorn. I mean, they bought Vimeo for like 1.4 billion. They bought AOL. They're like, they're one of their
Interesting.
like, so their apps are used by like a lot of people, like hundreds of millions of people daily. So, but to get this to be a locally thing algorithm, you really need to have like an MLX team full time. You need some funding, but we're quite good friends. Like the laboratory at University of Bologna and I are kind of, but
We can cut it out,
if
by
it
the way.
were
It's like, it's fine.
if to really like work on really optimizing the, which if you do in the future, it should 100% be possible to train it locally on your phone.
Would need that.
Yeah, totally, totally. It's totally going to be a game changer once you can do this on your phone. And I think in the future,
To build in, though, to be honest, in the consumer side of things, because I assume
Yeah.
the first thing. So I would assume if they're not completely retarded by then, which local Gaussian splatting with some
Yeah, they also launched like LLM.
yeah.
the idea would be just converting open source algorithms from CUDA to ML. Apple puts 2 engineers to do this. I would trust that way more, actually. Um, yeah,
I don't
yeah.
think there's
Especially
any
like
reason
with the
for this to
Vision
stop,
Pro.
right?
Another phone. And so if like a VR takes over, and you know, this is when the Apple Vision Pro came out. I was thinking, you know, what's the UI elements that are like 3D, and so like on your desk or whatever, that are like yeah, the sort of the primitive of or the them over to your friend or whatever that would
You're looking at a 2D phone, but interacting with a 3D object, like a really
100%.
excites me. Yeah. Instagram, acquire us, please. Acquire.
Yeah, Yeah, I think we can wrap it up, right?
Yeah.
I think it was a
So-
Yeah.
great talk.
So-
Obviously, I hope it wasn't too much talking.
I can yap about this for hours. No worries, mate. I had so much
Yeah.
fun. Thank you guys for having me.
Go.
So-
Don't forget us when you get.
Good luck to your
Cool.
to your venture.
Thank
Where
you.
to have it unflatten.
Public, nothing
Okay.
public.
Let's try to get him some LOIs, and then we.
To love it, because they are like, I can think of someone right now who I would, and he was using photogrammetry for all of his like art pieces, but now they ran into this like issue where it's just like too much work. So if it was like a unified API, I could just, because they have the images, they have videos of these things, so I could literally just post to this API, I would get a splat back, I would integrate it into the website, and they would be happy. And so it's like, for me, if this launches, I would probably instantly
you're my
use it.
dream customer. You're my ideal customer.
Yeah, I'm like the normie dev. I just want to
A dev who needs this. I want you as a customer.
But it's not just me, right? It's like, honestly,
Yeah.
I would say all creative
like,
agencies will eventually.
Not even that. Like even while this talk, I literally had like 4 or 5 ideas where you could just make product out of that.
Yeah, and I think you're being
Like
nice,
4 or
right?
5
Because
wrappers.
technically, like, why give us the, like, you could also just build this, and you could do this. You could, I don't know, build a Shopify app, right? And make huge.
Yeah.
I mean, maybe this is like higher ROI if it actually, like, if you get funded and it gets huge. I can see the vision for that, but the grifter way would be to just ship what you have, the pipeline, and then just build 50 Shopify apps and, like, I don't know, some other e-commerce garbage, right? And then
WooCommerce.
yeah, this would be the if you don't have a vision, right? If you don't have a vision, you go the e-com grifter route.
But then again, maybe
not saying it's a
action's
bad
not
thing,
bad, right?
Constantine, by the way. Not saying it's a bad.
Yeah.
Like, yeah.
Well,
Sure.
a
Yeah.
man's gotta
We've
eat.
thought about all of these. We will definitely update you guys once we have something working.
Yeah.
So
Cool.
stay in touch. Stay in touch, guys.
So, yeah. Bye.
Awesome. Thank you so
Alright.
much.
Peace out.